Okay, welcome to the AQA Level 2 Further Maths. This is a 2022 paper 2. This is a calculator paper. Alright, question number 1. Full factorisation, take out 6w, it's highest common factor of those two, so 6w lots of 2 plus 3w for question 1. For question 2, we know that -1 is halfway between the y coordinates, so if we add the y coordinates and halve them, we'll get -1. Solve the equation a is equal to -8. Question 3a, matrix multiplication. If you wanted to multiply the first matrix by 3, each part in it first, and then carry out the matrix multiplication, you can do, that's absolutely fine. I've just multiplied the two matrices first, and then multiplied each part by 3 second. Either way, you end up with 18, 36, and 0. For b, if we do 7 times 2 plus a squared times a, we'll get 78. That gives us a cubed being 64, so therefore a must be 4. And then the second multiplication, 2 times b plus -5 times a will be equal to 12. We know that a is 4, we can substitute that in and solve to find that b must be equal to 16. So a is 4, b is 16. Question 4. We get given the equation y plus 4x equals 6. Subtracting 4x on both sides, we can clearly see that the gradient of this line a is -4. We know that b is parallel to a, so if the gradient of a is -4, then the gradient of b will also be -4. We know that b passes through the point 2, 1, and so that's enough to construct the equation of the line b, y minus y1 equals mx minus x1. Substitute our points in. X is d when y is 2d, so we can take our simplified equation and substitute y for 2d, substitute x for d, so 2d equals -4 times d plus 9. Add 4d to both sides, 6d equals 9, so therefore d must be equal to 9 over 6, or 3 over 2, or 1.5, or 1.5. Any of the above is absolutely fine. Quadratic inequality, divide both sides by 3. X squared is less than 16, while the only negative integers that square to an answer under 16 are -3, -2, and -1. Question 6, prove algebraically that expression is always even. So I'm going to expand out the double brackets. I'm just going to be careful on the second part of that. I'm going to leave it all in brackets because we're subtracting all of it. And I can subtract each part one at a time. The 4n squareds will cancel. We get 4n subtract -4n, which is a10, and 1 subtract 1 is 0, leaving us with a10 on the numerator. Over 4 is 2n, and 2n is always an even number because it's a multiple of 2. Question 7. To be between 200,000 and 400,000, the first digit has to be a 2 or a 3, so there's 2 ways of doing that. There's 5 factorial ways of sort of sorting the remaining 5 numbers, and 2 times 5 factorial is 240. There's 240 ways of doing writing those numbers. For 8, we're going to differentiate the curve because we want the gradient to be 4. So differentiate the curve, equate it to 4, and then subtract 4 from both sides to give us a quadratic equal to 0. And then if you want to use the formula, that's what I've done here. I think it's probably easier. Completing the square is going to be a bit messy with this one. Plugging it into minus b plus minus the square root of b squared minus 4ac all over 2a. A is 3, b is -10, and c is -4. Plug all that in, and we get x to be 3.69 or -0.361. Both of those are given to 3 significant figures. Okay, so this linear sequence is increasing by 4k each time, so the next one's going to be 30 plus 12k. And then for b, We know that the 100th term is going to be 525. So we'll get 30, which is the first term, plus 99, lots of 4k. That's using the nth term of an arithmetic sequence. Expand it out, 30 plus 396k is equal to 525. Subtract 30 from both sides. Divide both sides by 396k is equal to 1.25. A plus n minus 1d, of course, for the start of that. That's a graph of D. Not much more to say. It just can't be any of the others. When x is 0, 2 to the power 0 is 1, 3 times 1 is 3. Question 11. So cos of x is going to be the adjacent over the hypotenuse. It tells us that a is greater than 5. So cos of x will be greater than or equal to the adjacent, which is 5 minus 3 over 4. 5 minus 3 is the adjacent, and 4 is the hypotenuse. Obviously cos of x will be bigger than that, say it's bigger than 5. That's the same as a half, and therefore x must be between 0 and 60, because cos of x greater than half is only within that range. Question 12. First thing I'm going to do is rewrite the equation in the form of something that's easy to differentiate. So 3x minus 2x to the minus 1 plus 3/4 x to the minus 2 multiplied by the power, subtract 1 from the power. Just be a little bit careful when subtracting 1 from a negative number. And then I'm going to rewrite that as fractions. So 2x to the minus 2 is the same as 2 over x squared, and minus 3 over 2x to the minus 3 is the same as minus 3 over 2x cubed. We want to find the gradient when x equals negative 1, so I'm going to substitute negative 1 into that. You didn't have to rewrite this as fractions if you didn't want to. You can just substitute negative 1 into the first version of the differential and plug that into a calculator. That would do the same thing. Either way, you end up with 3 plus 2 plus 1.5, which comes out as 6.5 or 6.5 or 13 over 2. Any of the above or equivalent is absolutely fine for 12. Question 13. So we've got ourselves a circle. AB is the diameter. That means the centre of the circle is going to be at the midpoint of AB. So I'm going to start by calculating that centre. So halfway between the x coordinates, halfway between the y coordinates, comes out as 1, 9. To find the radius, which is the other thing we need for the equation, to find the radius, I'm going to find the length AB and then halve it. You can show the numbers being plugged into the formula. Essentially it's just Pythagoras' formula. Anyway, the radius comes out as 10, as you can see. Half of that is 5, so the radius is 5. And so we'll get x minus 1 squared plus y minus 9 squared equals 5 squared, 25 here. Okay, question 14. We know that angle PSR, the one that it gives us, is 4 lots of x plus 15. So first thing I'm going to do is expand that out, 4x plus 60. We know that PQR is 40 degrees smaller than that, so subtracting 40 from 4x plus 60 is 4x plus 20, and we know those are opposite angles on a cyclic quadrilateral, and therefore they must sum to 180 degrees, allows me to construct an equation. 4x plus 20 plus 4x plus 60 is equal to 180. Collect the x's, bring the non-x's onto the right-hand side, divide both sides by 8. X will be equal to 12.5 degrees, or equivalent. Question 15. I'm going to start by getting a common denominator, so writing the first two fractions over 10. And then I've taken a fairly big jump on the right hand side, so the square root of x to the 6 over 4 is the same as x to the 3 over 2, and I've also flipped that to deal with the division symbol and turned it into multiplication. 5x over 10 plus 6x over 10 is 11x over 10, timesing by the 2 over x cubed. I've cancelled a load of stuff one at a time. You can cross cancel, of course, when multiplying fractions, leaving me with 11 over 5x squared as being fully simplified. If you've written 11 over 5, lots of x to the minus 2 outside, that's absolutely fine too. Question 16. We've got ourselves an isosceles triangle. Well, the two base angles on an isosceles triangle will be the same, so I can draw myself an extra y in there. We know that the area of the triangle is 120 centimeters squared, so I'm going to use a half AB sine C. That C has to be the angle in between the two lengths, so if I'm using 16 as my A and my B, we're looking at that angle between the two lengths of 16, which will be 180, subtract 2 lots of y. That will be equal to 120. Simplify the left-hand side. Half of 16 squared is 128. Divide both sides by 128. We get an expression for sine of 180 minus 2y is equal to 120 over 128. Inverse sine of 120 over 128 is 69.6, etc., etc. And therefore, if I subtract that from 180 and halve it, I'll work out each one of these y's. And we can just plug that into the calculator. Remember not to round partway through a question. Use the answer function on your calculator, and you'll get y to be 55.2 degrees. Question 17. 3 sets of simultaneous equations. I'm just going to go for an algebraic approach to this one. You could have done it in a number of different ways, solving 3 sets of simultaneous equations. You could turn it into various different things. You can do things like row reduction if you fancy that to show off. You can turn it into a matrix if you're capable of finding the determinant of a 3 by 3 matrix. However, I think the simplest way of doing this one is just an algebraic one. I've added the first 2 equations together to eliminate the b's. And I've taken 3 lots of the third equation and subtracted the first equation to get another equation that eliminates the b's, and so therefore I've got 2 equations just involving a and c. I've cancelled the a's to find that c is equal to 3. Once you've got c is equal to 3, you can go back to any of the other equations that involve c and work out what the corresponding a and b values are. This is just one way of a multitude of different ways of solving this. Any way that ends up with a being -2, b being 4, and c being 3, as long as you've shown clear algebraic working, is fine. All right, question 18. We've got sort of this triangle ACP, which is floating inside the box. P is at the top, and obviously A and C are at the 2 corners at the bottom. Start off by finding A to C by doing Pythagoras on ABC. It comes out as 41 degrees. To find A to P, well, I've split the H to G up into 12 to 28. Well, we know that H to P to G is 3 to 7, so we can divide the length into 40 into 12 and 28 for that one. So A to P, doing Pythagoras in 3 dimensions there. 9 squared plus 20 squared plus 12 squared. Add those 3 together, square root them, and we get A to P being 25. Lastly, we need P to C. Well, P to C sits on the back face of the cuboid. We've got P to G being 28, and we've got G to C as 20, so Pythagoras on that gives me a simplified 4 root 74. We've now got 3 lengths on our triangle that's suspended in midair, and using the cosine rule, the one where we can find an angle, so b squared plus c squared minus a squared over 2bc, and then finding inverse cos of that. Plug all that into your calculator, and you'll get that the angle we want, APC, will come out as 85.7 degrees. Right, question 19, just a triple bracket expansion. Do this in any order. I've done the first two first. 6x squared minus x minus 12. And then the second expansion by multiplying all that by 5x minus 2. You can do this in more steps. I've expanded and then collected like terms in one go, but I would recommend being slightly more careful than that in an exam. Question 20, the factor theorem. So we do need to plug a half into it. You can't factorise out 2x minus 1 from f of x initially, because that's not what the factor theorem says to do. You must plug a half into the function. When you plug a half into the function and get 0 out, it's that outcome which implies that 2x minus 1 must be a factor of the original function. That is the factor theorem in action, and the question says use the factor theorem. It does not say factorise. If you factorise, that's no good. However, for B, to prove that it has exactly two solutions, we are now going to factorise. So we've got the original function equal to 0. I'm going to factorise out 2x minus 1. You can do this using long division if you like. I like to do these in my head, but it's entirely up to you. Some people like just factorising out a linear expression from a cubic like I have, or some people much prefer to just carry out the long division. Nothing wrong. Either way, the quotient you're left with, x squared plus 6x plus 9, factorises to x plus 3 squared. And therefore the solutions to f of x being equal to 0 must come from that, and the only two solutions that come from that are a half and negative 3, and there are no other solutions. So those are the only two solutions, and therefore to answer the question directly, we have shown that there are exactly two solutions, and those are x equals a half and x equals negative 3. There are no others. Question 21, so values between 0 and 360 degrees. First step is to divide both sides by 2. I'm going to square root. When we square root, remember there are two square roots of 3 over 2. There's a positive one and a negative one, so I'm going to separate those into two separate sections. For the positive one, doing inverse tan of the square root of 3 over 2 gives me an x value of 50.8 degrees. With tan, up to you how you calculate the others. Adding 180 degrees is the simplest way. So as soon as you have a solution, add 180 degrees to get the next one and keep repeating until you're out of the range. For the negative root 3 over 2, you get negative 50.8. Adding 180 to negative 50.8 gets you to the next one, and then again. And then lastly, I'm going to write all the solutions that are within the range in ascending order just to make it look pretty. And there are 4 here. Question 22, so it says using powers of 2, so I'm going to use powers of 2. 16 is the same as 2 to the power of 4, so 16 to the x is going to be the same as 2 to the power of 4 to the power of x, or if you prefer 2 to the power of 4x. 1 over 2 to the 3x is 2 to the minus 3x. And then, so 2 to the power of 4x squared is 2 to the power of minus 3x, so 4x squared must be equal to minus 3x, 4x squared plus 3x must be equal to 0, factorise out the x. We'd get two solutions, x equals 0, x equals negative 3 over 4. However, the question says work out the non-zero value of x, so let's get rid of that, x equals 0, and take x equals negative 3 over 4. Well done if you managed to get that one. Bye.